Welcome to SchoolQuizz. So this side Anjali Singh, and today we are going to start the third session of motion. Okay, so in the first session we learned about the motion, how we can recognize about the motion, as well as about the distance and the displacement. And in the session, as well as distance as well as the displacement. I think now in the second session we studied about the uniform motion and non-uniform motion, and after that speed. So in the third session I'd like to start. Yes, so you can see about the velocity. So what is the velocity here? You can see velocity means the distance traveled in a given direction. The distance traveled in a given direction, as I earlier told you, the distance is traveling within a particular direction, that is denoted as displacement. Clear, everyone? So here, either you write distance traveled in a particular direction or in a given direction, or you can write as displacement upon time taken. Okay, so here velocity is the displacement upon time. Okay, so you'll write in the form of distance also, as well as in the form of displacement also. But when you write distance, so it is very much necessary that you are going to mention about the direction also. Clear, everyone? So here the speed of the car is actually gives how the car is moving. It is either moving fast or slow. Clear? Here the SI unit. Okay, if we will talk about the SI unit, so what will be the SI unit? I want to tell you about the SI unit. Clear? So that will be the SI unit will be velocity is equals to speed in a particular direction upon time. So that will be denoted as displacement also. So SI unit of displacement, yeah, as I told you, that is meter, and SI unit of time is second. So that will be meter per second. Clear, everyone? So that will be meter per second. Okay, now, okay, yeah, that is muted. Actually, I'm muting my mobile, but that is already muted. Okay, so this is now. Okay, I'll erase it. Okay, so now, yeah, we'll move towards the next slide. Yeah, in the next slide, you can see. Okay, first I'll use the erase option. That is better. Then only you'll able to understand. Now, as I told you, velocity is the displacement upon time. You can see the formula is also given in that form. Now, here the yes, displacement upon time taken. Now, SI unit is also written like that. That is meter upon second, or you can say meter per second. The second will go upside, so that will be in the form of -1. Now, here, is the difference? Actually, we'll see the difference between the speed and the velocity also. So, here speed is a very good. Here speed is a scalar quantity, but the velocity is a vector quantity. Why velocity is a vector quantity? Because velocity will tell you about displacement upon time taken. Okay, displacement upon time taken, and the displacement is a vector quantity. If the displacement is a vector quantity, so definitely velocity also be the vector quantity. I want to write it, then only you'll see. See, speed is a scalar quantity. Velocity is a vector quantity. Why? Because velocity formula is displacement upon time. Okay. Velocity formula is displacement upon time. And the unit of displacement is already, yeah, meter. Okay. And this is second, as well as displacement is a vector quantity. Displacement is a vector quantity. So definitely velocity will also be a vector quantity. Clear, everyone? I think that is clear to you. Clear? Why it is a vector quantity and what is the meaning of vector quantity? Velocities are expressed without mentioning direction. For the sake of convenience, the direction is assumed without being stated. The direction of velocity is as same as the direction of displacement. Why? Because displacement is always considering the direction, as well as velocity is also considering the direction. Here, if I'll give you example, a common example, like you went to your house and the house is in north direction. Okay, so you went to your house, so that is the distance. You went to your house that is in north direction, that will be the displacement. Okay, student, so here in north direction is also about the velocity. The major difference between the speed and velocity is speed is a scalar quantity and velocity is a vector quantity. Clear? Okay. Okay. So that I'll rub it. Then only we'll move towards the next slide. This slide is also over. So now next is distance travel is also is equals to average velocity into time. So whatsoever velocity is acquired in a particular distance, that will be the average velocity with a different time interval. Clear? In a different time interval, how much velocity is acquired, so that will be act as a average velocity. Now, uniform velocity. What is uniform velocity, or you can say constant velocity? So uniform velocity is about a body has a uniform velocity. It means the velocity moves, or you can say the velocity acquires equal distance in an equal interval of time. Okay, means the body has uniform velocity in equal interval of time. A body is acquiring uniform velocity in equal interval of time. So that is about the uniform velocity. Clear? Okay. So like here you can say, yeah, actually it is not clearly visible. By keeping the speed constant, but by changing the direction. Okay. So this is the example. Okay. By changing the speed of the body, when you'll change the speed of the body also. Okay, body means an object only. So these are the examples. Speed and velocity are not always equal in magnitude. Okay, so this is the one important statement. Why speed and velocity are not equal in magnitude? In some cases it is not equal, because when you can see here, a boy is moving from his home to the shop. You can see from home to the shop. Clear? So he started from home and to the shop. Okay, sorry, I repeated 2 times, 3 times. Okay, so let's see. This is the distance, or you can see the speed. Okay, how much speed is acquired? Like 100 meter per second. Okay, this is the speed. Yeah, distance traveled 100 meter, time taken 50 seconds. So the speed is 2 meter per second. But about the velocity, Here velocity is also 2 meter per second because the man is only going from this point to that point. Suppose the man has to move from shop to the home. So in that case, displacement will be 0, as I explained to you earlier, because 100 meter minus 100 meter. So that will be equal to 0. That will be equal to 0. So it means what? Here the displacement is 0. So definitely velocity will also be 0. But the speed will be 4 meter per second because distance travel is 100 meter plus 100 meter. That will be 200 meter and the time taken is 50 seconds. So that will be 4 meter per seconds. Clear? Now, the magnitude of speed and velocity of a moving body is equal only if the body moves in a single straight line. When it is going to be same speed and the velocity when the body is moving in a single straight line. Okay, not moving in another direction, because whenever we are writing about the speed we are not recognizing the direction, but whenever we are talking about the velocity, so always we will consider the direction also. Clear? I think this is clear to you. Okay, so yeah, whatsoever given in the slide that already I explained you, you can see the velocity will be 0. Why? Because the man returns. But here I think a different example is given. Okay, no, same. Going and coming. Going time 100, coming time 100. So that will be 200. Here 100 minus 100, that will be 0. So that will be 0 meter per second. Clear? Now, the average speed of a moving body can never be 0. Speed can never be 0, but the velocity will be 0. So I want to tell you that please mark it as a very special. The average speed of a moving body, okay, that is very important. Moving body can never be 0, but the average velocity of a moving body can be 0. Clear? That is very important point, students. That is very important point. Because in the conceptual type, definitely they can be same. Yeah, they can be same. But in when it is same, when the body is moving in a straight line, and it will be different also. When it will be different, when there will be body moving in another direction also. So that time they both acting like a different. Clear? Now examples are given. I'm not going to rub this. Okay, so a bus covers a bus covers yeah, a bus covers distance of 250 kilometer from home from Delhi to Jaipur toward west in 5 hours. Okay, in the morning and return to Delhi in the evening, covering the same distance 250 kilometer in the same time. That will be 5 hours. Okay, so here the distance is given as well as the time. So speed will be, as I told you, distance upon time. So 250 and 250, that will be 500 upon 10. Okay, this will be same. Now velocity, definitely it is one time it is going, another time it is coming. So 250 minus 250. Time will always be added. Okay, students, please keep in mind time will always be added. So time will be like 10. So the average velocity of the bus will be 0 and the average speed will be, here what it is given, 50 meter 50 kilometer per hour. Clear? So that is whole about the uh, that is whole about the velocity. So in the next class we will study about the acceleration. Clear, everyone? So today we read about the velocity, how velocity is different from the speed, as well as I had given you one example which is related to the velocity. So please read it and revise it and stay healthy. Thank you.